All right, our lesson is called the mean value theorem, and then we'll do Rawls theorem in a moment. This theorem, let's just clarify some things about what this theorem is saying. First of all, this theorem is called an existence theorem, and we learned another existence theorem before. Focus here. What's going on? The other existence theorem that we learned before is called the IVT, the intermediate value theorem. And so all these theorems do is just prove something exists. And it's not necessarily groundbreaking. It's just saying like, this must exist. This must be true. What the intermediate value theorem proved is that a y value exists. So we just basically said like, if the temperature went from 60 degrees to 80 degrees, then it must have existed at 73 degrees at some point, like some y coordinate between 60 and 80 degrees would exist. The mean value theorem, mean here is the average, the word average there. So what this theorem is saying is just an average value exists. But the average they're talking about here, when we talk about an average, we're saying like the average rate. So we'll kind of dive deeper into that, but it's not the same as the y value, it's an average value. So let's talk about average value, average rates, and then I'll show you how we create the mean value theorem. So let's say we had a graph here, an x and y graph, and let's say, you know, it could be like a stock price or something like that, starting here, and it has some ups and downs. Well, if you were to, you know, tell how this stock is doing or how it's done from start to finish, most people aren't going to say it went up and then it went down and went up. They would just give you the average rate that this stock has returned. To find the average rate, you would just do that by connecting and finding the slope from start to finish. Just literally all you need is the first point and the last point, and finding that as a slope. This would be called the secant line. And so to find that slope would be by doing the y value, like this is just, you know, truly slope y2 minus y1. But this value, instead of calling it y2, we can call it f of b. And then this value, we could call it f of a. Those are the y values. So this rise over run would be y2 would be f of b minus y1 would be f of a over b minus a. And so that's the slope of the average rate of change. That's the average rate of change. All right, so what we now say with the mean value theorem is this, that at some point throughout this stock's ups and downs, it must have had an instantaneous rate that is equal to this average rate. So the average rate is this secant line's slope. The instantaneous rate would be a tangent line's slope. So if I was to look at the tangent lines throughout here, I am, with the mean value theorem, saying at least at some moment, the slope of my tangent is equal to this slope, or parallel to this slope. So there must have been like maybe a point right here. It's probably off a little bit, but at that slope, it's the exact same slope as this. This would be the instantaneous rate of change. And it has to happen at least once between A to B, somewhere in between A to B. It happens, looks like here, maybe a second time. So it could happen multiple times, at least once, that this tangent line, the instantaneous rate is equal to that rate. So to complete this is the average rate we're saying must have been equal to the instantaneous rate at some point. So some point between A and B, we can make up a letter here of where that happened. Typically, they actually use C. And then, so this would be like C1, and then it happened a second time, it could be like C2. So the tangent line would be written as a derivative, this derivative at C would be the slope of the tangent versus is equal to the slope of the secant, or the average. So this represents, anytime we find a derivative, it represents the instantaneous, I did not spell that right, instantaneous rate of change. So what the mean value theorem is saying is that the instantaneous rate will equal the average rate, at least at one moment throughout the graph. So this is the formula, I guess, that we would use to kind of set up and plug into. But let me put into our notes now, like the official mean value theorem definition here, so that we have our notes filled in correctly. If you want to draw, maybe go back and draw this shape to help, I think we should. I think that's a good idea. So let me just draw it really quickly here. Okay. Okay, now I'll write the theorem here. So what needs to happen is f, it will be our function, has to be continuous in order for this to even work, from A to B, and that includes A and B, so we put brackets on there. Then it also needs to be differentiable, so we can find those tangent lines. So, and differentiable. But differentiable from A to B, you can't have a derivative at an end point, so you can't put brackets. You got to put parentheses for differentiable. So if that is the case, if we are continuous and differentiable, then there exists at least one C on A to B. So that C value is in between. There could be 1 or 2 or 3 or more, at least one though. At least one moment such that the derivative at C equals the average rate Sorry for this, looks sloppy, this parenthesis, but I think you get the idea. And then I'm just going to point out to add to this that this value is the instantaneous rate. And then this value is the average rate. Okay. Rawls theorem is basically the same idea as the mean value theorem, except a specific case. So here's what's specific about it. It's saying that there is a point that you start at is the same exact y value as the point that you end at. So the graph could go up or down, but start to stop is the same exact y value. And so that's really key here, is that f of A equals f of B. Well, what that would mean is, let's say our graph goes like this, something like that. The average rate is by connecting the secant line from start to finish, would be a slope of 0 every time the f of B is the same as f of A. So therefore, it's proving that there exists at least some other instantaneous rate of change on this curve that also has a slope of 0. And so if I look at the tangent lines, there must be at least one time, maybe more, in this case there's more, that also has a slope of 0. So there's a bunch of c values here going on here, but there's got to be at least one value here. So the mean value theorem is basically just the special case when the slope has to be 0. So here's our mean value theorem written out. If f is continuous on a to b and differentiable between a and b, can't be differentiable at the endpoints. And there's one other thing to mention here is, and the f of b and is the same as the f of a, the y values are the same. So I have to put this in the situation here. Then there exists, I don't know why I didn't write it up here, but whatever, at least one c on the interval from a to b, so 1c, such that the instantaneous rate at c equals, now in this case it's technically equals the average rate just like up here, except we know if f of a equals f of b, the average rate automatically has to be a slope of 0. So it's just simpler. Instead of putting this in here, it just equals 0 here. Now, the idea here is the mean value theorem is like the overarching theorem, and Rawls is a specific case. So technically, if you get a situation where f of b equals f of a, you could just use this original mean value theorem. So some problems may technically say the word mean value theorem, even though it ends up happening the Rawls case where it equals 0, but otherwise it's just, it's all the same idea. For mean value theorem, just one last thing to know is that you could just shorten this and just call it MVT. Okay, good luck. Let's do some problems.